In this video, we'll take the homework sheet on solving linear quadratic systems. For the first question, you're given a linear quadratic system. You're just asked to find the solutions. So pretty straightforward. Hopefully, after you set equal to 0, you didn't use a quadratic formula and you just factored. And once you find the x-coordinates of the solutions, or the x-coordinates for the points of intersection, then you can solve for the y-coordinates. I would prefer to use a linear function, but you could use a quadratic function if you want. So, yep, the two solutions for the linear quadratic systems for both 1a and 1b. Okay, what about 2? For number 2, you're trying to find out whether there's going to be one solution, two solutions, or no solutions for this linear quadratic system. So you don't have to find a solution, you have to know how many solutions there are. So set equal to 0. Instead of solving, I'm just going to use a discriminant. It's positive, so you're going to have 2 points of intersection, 2 solutions to this system. For 2b, basically the same as 2a, but this time discriminant is less than 0, so there's no solutions to this linear quadratic system. There are no points of intersection. For 3, they say that there's one solution to this linear quadratic system, and if there's one solution to this linear quadratic system, I can use that to solve for the y-intercept of this line, because after I set it equal to 0, the discriminant must be equal to 0. So I simplify and I can solve for b, which is a y-intercept. So same strategy for 3b. Set the discriminant equal to 0 because they gave us the fact that there is one point of intersection between the line and the parabola. If they did not tell us that, there's really no way to solve for the y-intercept. I have no clue what it is. It could be anything. All right, so what about 4 here? They gave us the cost function and the revenue function, and they ask us after how many items produced will let the company break even. So basically, you solve the linear quadratic system. So we're looking at approximately 41 items in order to break even. All right, so number 5, very common question. They're asking you, for what values of k will there be 2 solutions, 1 solution, and no solutions? So you have to work with the discriminant. Okay, now this one's a little harder to understand. Okay, so discriminant, if you simplify it, you'll get negative 4k plus 60. Negative 4k plus 60. Now in 5a, you're asking when it intersects 2 times. So you want the discriminant to be positive. So really study this. Okay, you can think of this as a line with a slope of negative 4 and a y-intercept of 60. So when is this greater than 0? Well, if you think about it long enough, you'll see that k is less than 15. If k is less than 15, then the discriminant is positive. Now, if k is equal to 15, then the discriminant is 0. And lastly, if k is greater than 15, then the discriminant is negative. Okay? Another way so I'm going to draw the line for you. Let's say y here. So 15 okay, so you really want to know when it's negative, when it's positive. So this is when it's positive. That's when the discriminant is positive, right? I don't care what number it is, I want to know when it's positive. So when k is less than 15, 2 solutions. When k is greater than 15, the discriminant is negative. What if k was 15? Well, k is 15, then the discriminant is 0. So if you wanted to have 2 solutions, k has to be less than 15. if you want no solutions, then you want k to be greater than 15. Okay, so this is the graph of negative 4k plus y equals negative 4k plus 60, because we simplified the discriminant to be negative 4k plus 60. So basically the different y values here represents the different values of the discriminants given the value of k. Okay, so hopefully the graph helps there. All right, so then we have this question where you have a tank that's draining and tank that's filling. When are the two volumes the same? So be careful with the volume of the draining tank. You find the volume of the full tank and then subtract it by the rate at which it's being drained. Anyways, quadratic equation. Quadratic formula, since it's not factorable. So after about 109.3 seconds, the tanks will have the same volume. Okay, so that's your solutions for the linear quadratic homework sheet.